So this is a test of independence, or test to see if there's an association between a set of variables. And unlike the two-way table, is we have, get a pen going here. We have, instead of just a bunch of categories or one set of numbers, we have a couple of different choices for nausea, no nausea, or placebo, or the actual drug treatment. So this is called a two-way table because there's two rows this way, two columns this way. It's also called a contingency table. I don't usually use that term, but it is another way to look at it. So this is a chi-square test. Basically, what it's telling us to do is we're going to test to see if there's an association between a set of variables. And these are categories, not quantitative. So that's why, because they're categorical variables, we can't calculate a correlation or anything like that. So we need this other tool to do with this. And you actually did this earlier in the year, where I had you find the percentages, and you had to look and see if the percentages were the same. It worked. It was kind of lame. This is the better way to do it. But you didn't have enough background before that. So basically what we're going to do is a chi-square test, and it's kind of like what we did yesterday with the goodness fit test. Where we're going to say there's no association between these variables. There's no relationship. They're independent of another way to say this is they are independent. Test for independence. So there's no association with BH1, HA, and for H1 or HA there is an association. There is something going on, whether or not somebody's suffering nausea or not, depending whether or not they're taking the treatment. So there is an association here. Okay. Now, a couple of things we're going to worry about. We're going to ask ourselves, is this a random sample? Well, let's see. This is studied in clinical trials. They don't tell us that this is a random sample, but if it's a clinical trial, they usually use random sampling, random assignment to treatments, random treatment. So we're assuming there's a random sample. The other issue we got to worry about, we got categories. There's also has to be counts, not percentages. So these are our counts of people. And the other issue is these counts have to be at least 5. Okay, in this case, they certainly are. So if you're trying to run one of these tests and you don't have at least 5 in any one category, then you know you can't use the chi-square test for independence. Use one of those non-parametric tests, what we'll look at a little while later. Okay, so like we did with goodness to fit tests, you have some observed numbers, and these are the observed numbers, but you also have to do some expected numbers. In class, I did this all out by hand. I think what I'm going to do for this video is set up a spreadsheet for you for this. You can either just copy down the numbers or you can follow along with the spreadsheet. So what I did is I opened up the spreadsheet, the numbers. Here, let me get rid of that ink. Here, how do I do this? I'm going to clear all drawing. There we go. So then what I'm going to do is I put the numbers in here, and these should be observed. I'm going to write O for that. Now I'm going to calculate the expected. And the way you do the expected values is you have to get some totals. So we're going to get some totals for the rows, totals for the columns. Total, right? Word total here also. And then I'm going to add up these numbers. Well, that's going to be 795 plus 10 would be 205 or 805, right? But I'm going to be really lazy and let the computer do this. So that's the sum of 805. And then same thing there. I'm going to add those two numbers, but again, I'm going to let the spreadsheet do it. Now I got to add up these rows. So that means 10 plus 30 should be 40. And now we're going to add up all of them. And so this is the table total. This is the sum of all these numbers here in the table. Okay, so that's the table total. Now, in order to calculate the expected values, what you need to do is and let me come back and do some more writing. What you do to fill in any one cell, and we've got 4 expected values that we have to calculate because there's 4 in our two-way table. What you do is you take the row total times the column total. I'm going to run out of room. Divide that by the table total. That's how you calculate the expected value. So I think you'll see in a minute here, this makes a lot of sense. Let me copy down things here. I guess I got to clear my drawing. Okay. Copy these. Copy these. Okay. So what I'm going to do is I'm going to take the 4, because I'm looking for the cell that's in the first row and the first column. I'm going to take the first row total, multiply it by the column total, and then I'm going to divide it by the table total. Okay, so I could do that by hand. In fact, why don't I? I won't do any kind of filling down. So I'm going to do equals. I'm going to click on the 40 times 305 divided by the table total. And without doing some cell locking, I won't be able to do any filling. So I'm going to do this by hand since there's only 4 of them. So then for this one, I'm going to take that row total, because I'm still in row 1, but now I'm going to multiply by the column 2 total, which is the 821, divided by the table total. So equals that times that column total divided by the table total. Okay, I'm going to do the same thing. Equals, remember, now I got to do the second row, because I'm in the second row, times the first column divided by the table total. And what did I just do? Gave it too much information. And then same here, equals, what am I going to multiply? Hope you said row 2 total times column 2 total divided by table total. So those are the expected values. Then just like with goodness of fit, we can do the observed values minus the expected values. Let me copy and go in here. You know I'm going to let you use technology for this, but we got to walk through a couple of these by hand. So observed minus expected. So for the first nausea with a placebo, I had 10 people experience nausea in the placebo. I'm going to take away the expected value for those people. So I'm going to do equals, click on the 10 minus the expected. Of course, you can do that by hand. And we do the same thing here, equals that minus the expected. And look at that, the same thing. Equals that minus the expected equals that. Whoops, something's not right here. Equals that cell minus the expected. Okay. Then we're going to take and square each of those differences. So I do some highlighting here to get some copying done. So I want to take each of those differences and square it. So the easy way to do that is when I click on it, equals caret 2. And of course, because I know I'm always just squaring those cells, I'm just going to do it like that. Now the next to last thing is we're going to take those square differences and divide them by the expected values. So okay, so I'm going to take equals. I'm going to click on that expected value for that placebo and nausea and divide it by that expected value. Do the same thing here, equals, click on that squared term, divide it by the expected. I probably could do some filling across, filling down here, but we'll do it this way. That squared value divided by the expected. One last one here, equals, divided by that squared value divided by the expected. And then to find the chi-squared value, remember chi-squared, that funny looking x, we're going to find the sum of all the four of those numbers. And that's my chi-square number. If we did this right. Okay. Now, next question is, so that's my test statistic. I already know HO and HA, though I erased them, but we can remember what they are. And now I'm going to find a p-value. Now, you have a calculator that'll do this. Okay, so that. So on our calculator, if you do, let me clear, can I clear this? Yes, clear. There. So what we're going to do is, I'm going to do second bars to get that distribution. Yeah. Second, I didn't do something right. Second bars. Here we go. And if you scroll down, you'll see chi-square CDF. So choice 8. And my lower bound is my chi-square test statistic, which was what? 24.8. And then my upper, I'm just going to pick some ridiculously large number, because remember, these are like a right-tailed distribution. Now, degrees of freedom, a little bit different. What you do with degrees of freedom is you do number of rows minus 1 times the number of columns minus 1. So 2 minus 1 is 1. Then across the top, 2 minus 1 is 1. So 1 times 1 is 1 degree of freedom. Then that gave me the p-value. That is essentially 0, right? 6.4 times 10 to the negative 7. Very small p-value. That means we're going to reject HO. Looks like there is an association whether or not somebody took Chantrix and experienced nausea or whether they didn't. So there's something going on here. We can't really say yet whether the Chantrix people had more nausea than the people who took the placebo. It looks it, but we would have to really do some other tests to see which is the bigger difference. Okay, so that's a chi-square test for that data. Why don't I write down, I'll make sure to get the degrees of freedom for a chi-square test for association. So degrees of freedom equals the number of rows minus 1 times the number of columns minus 1. Okay, that's how you get the degrees of freedom. Maybe I should put number on the top. Number on the top. And that's what you missed in class today. Oh, maybe I should show you how to do this with the calculator. So, there, let's clear that ink. What you got to do to run a chi-square test on a graphing calculator is you got to get that data into a matrix. And the way you get data into a matrix is you do second matrix, the x to the negative 1. Maybe I should make sure I do that with a pointer. So I did second matrix, And then we want to come over and edit. So come over to edit, press enter. And we've got a we got a 2 by 2 matrix we're entering, right? 2 rows, 2 columns. And we're just going to type in those numbers, 10 and 30, and 795, and 791. Okay, then we're going to quit the screen. And then we're going to run stat test. Come find your chi-square test, not the goodness of fit test, but the chi-square test. And press enter. And ask you, where'd you put your observed values? Well, we just put those in matrix A. Where do you want to store the expected? Notice you don't have to calculate those expected values. Then we're going to hit calculate. And, ooh, I got a different chi-squared number. That's not good. I must have made a mistake somewhere in my calculations. I'll have to go take a look. However, p-value is still pretty small. I can reject HO. Degrees of freedom is right. All right, so that's what you do. Maybe I'll give you my answers to the next question, so we did those in class, so that way I don't have to walk you through it on a video. But give it a whirl. Always come back and watch the video, or come see me. Need some help.